Hello, everyone. My name is Sanjeev, and thank you for attending today's webinar, Stipple, Building an Interactive App for Data Exploration and Model Explanation. Today's webinar will be led by Jeremy. He recently joined as a sales engineer at Julia Computing. Earlier, he was responsible for algorithmic and technological developments at investment firm EvoWest. He previously held various analytical and R&D roles for over 8 years as an actuary at Intact Financial Corp. And in case you have any questions during the webinar, you can type it in the chat section, and we will answer it during the Q&A session. Over to you, Jeremy.
Great, thanks, Sanjeev, for the introduction. Let me know if there's anything you'd like. As he mentioned, if there's any question you'd like to ask, don't hesitate. And we'll go straight into the meat of the content for today's webinar. So the idea is to have an interactive application, and we'll start first to look at the different assets that will help us develop this interactive application, namely Genie and Stipple. So Genie is the web framework built in Julia, and it's a general web development framework. And Stipple is an extension to that framework that provides utilities to have the reactive component necessary for the development of such interactive application. Following this first introduction, we will move into building the required assets to build those. Essentially the visualizations that we want that are of interest for our dashboard. And namely, we'll look at especially the SHAP, so the Shapley explanation for model explanation. And then we will wrap this up together in building a complete application with interactivity that will allow us to explore and play around the various features of our model. So just to get back in the context of with what we're going to play with today. This webinar is intended to be a follow-up of the previous webinar held in February, named End-to-End Machine Learning Workflow using Julia. So in this previous webinar, what we did was to build this complete analytical workflow going from the data extraction down to the deployment. And now, what we're going to do today is build upon what we did at this webinar, namely take this the inference of our models and try to understand how does this inference performs, and how can we compare the performance, for example, of the different models that we built. So we were having a Flux machine learning model, as well as a gradient boosted tree model built with Evo trees. So this is what we're going to work with. And if you want to put yourself more in the context, well, there's that YouTube link that you can you should easily be able to find with this title of the webinar, or look at the code directly. It's on the scoring engine demo, the GL, on the Julia Computing organization. And today we will work on the branch -172. That refers to the Julia version 172, on which we built this dashboard. And for further context about the data, there's the AI crowd that held the insurance pricing challenge. So this is where we took the data sets to make the demonstration of our modeling, and today of our interactive application. Now let's jump into Genie. So Genie is a full stack web development framework. It follows a model view controller architecture. What that means is essentially that we have a framework where when we will access the endpoint, so you can think of the endpoint as the URL address. This will trigger the our backend that is built in Julia, and that will be the model that returns some assets. So for example, for an endpoint, you might have some interest in calling a backend or a database in SQL and return some relevant data for that user and display those. So this is kind of the model that will represent this organization of the data. Then there's the view. So this is something that is essentially, you can think of the templates and the HTML that is rendered to the user. And then the controller is that the Julia functions that will make the bridge the gap between this model of our data and the views that are rendered as HTML pages. So Genie comes with the integration with the various SQL backends. So we can think of the most popular one like SQLite, MySQL, or Postgres SQL. And there are also a couple of other extensions available. I can rapidly think of, for example, authentication or authorization. In this later case, it follows a role and permission based model. So the idea is to associate different user with different role and associate those role with permissions to the various assets. This can allows you to control who can access a given endpoint to the website, or even have fine-grained control, for example, to change what are the components to be displayed based on whether the user has certain rights and permissions for your web page. Let's illustrate how this behaves. So we'll create an application using using Genie, just to illustrate how it works. And this will serve as since it's the foundation basis on which we can build our application with Stipple. So let's start building a first Genie app. This is fairly straightforward. There's a lot of helper functions to help us get started. So here I've just started a Genie, a Julia REPL session, and I'm using Genie. And I will now create a new app. So there's a new app function and MVC, and we'll call it a super app. And this will create us, will generate like everything needed to have our new app in place. So here what we have a message asking us if we want to have a backend in place. We'll skip this step at this stage, but you can see that you could have select, for example, having a SQLite backend server, and this will also put in place the few necessary scripts in order to have integration with a database. So now our application is having some pre-compilation, and the application should automatically start, and we'll see how that plays out. Roots are set, and now the server is ready. We'll follow the link, and this will should get us to our should render some content for our application. And here we go. We have this is the welcome page for the default application built out of Genie. Now we can ask ourselves, how did we get there? How did we get this content rendered? This is controlled actually with the different routes. So what we're being served right now is the result from serving the static file welcome.html. So this is the main entry point, and the content welcome.html can be found here in the public under the public folder, and there's a welcome HTML. So here, this is just simple raw HTML page, and this is what we get served. But when we there's other ways to serve our content, obviously. when we have more complex use case. And often what we'll be interested in is this HTML, which take various flavors, but you can think of HTML as being simply a way to say, well, here's a HTML string and render it as HTML content. So for example, we could have a root named hello, in which we would render this straight HTML content. Obviously, this is of limited interest, and it's not necessarily very interesting to write a full HTML page out of a string. But the idea is that Genie uses is essentially this, is having Julia return and generate HTML content, so that we can have this control that if we call hello, we'll have our Julia backend generate the templates and the views that we want. And Genie comes with some helpers, for example, layouts, so we can have a base template in which the content, the more interactive content can be generated and will be put into the yield content here. So here I've got into the app section, and in the under the layout, we can develop those kind of base layouts that will serve as a template for our web page. So I'll let the interested users continue their exploration for the Genie page, but at this point, I just wanted to give you like the really core foundation of how Genie works, as Stipple actually built upon this Genie framework, so it will help understand what is happening when we build a Stipple app. So now let's look at Stipple. So Stipple extends the Genie functionality in order to have the reactivity component. In order to have this reactivity, typically we'll want to have a live connection between our backend server and our front-end component. And this communication will typically happen through a WebSocket connection. And with the Stipple, what it performs for the front-end is having a Vue.js model. So the idea for the developer is to think both in terms of the UI, so the page, how the components should look like on the user side, and how does the actual raw information, the raw data, should be developed on the server side. This is very similar for those who have been having experience, for example, with the Shiny apps in the R ecosystem, or you can think as well as the Dash from Plotly, available in Julia and also R or Python. So the mental model is not so much different, but you can recognize that the components are fairly well separated when it comes to developing a Stipple application, which facilitates the integration of our raw Julia code. And this is, I think, what makes the strength of this framework for building application out of already code that we have developed. For example, the visualizations that we will build with Plotly in the upcoming slides. So here to give you the example of the three main components. On the server side, we'll have a model. So you can think of the model as the structure that contains all the reactive elements that we want to bring to our front end. So for example, here we have three elements to this model, namely the feature that is a string, sample size that is an integer, and resample that is a Boolean value. And these will be the assets that we want to bring to our front end. The other component to have interactivity is to define the handling of this model. So it's about to say, well, how should this content or this model assets to behave if there's a reactivity on the front end. So we can think of, for example, if there's an action on the variable is ready, what should we do? So to do that, we can use the on function. So you can translate this as, well, if there's something happening on the model is ready component, then do something. And this do something can be to update the information that is part of our model structure. And because we are having this connection with the UI, well, then our UI will display accordingly the value that is contained in our model. Here on the model, what we have is essentially a page that is an helper function that provides the ability to develop the web page component with some common function, for example, to develop the HTML elements. Here we have, first example, the heading. So here it's just a heading component of a HTML page. You can here recognize the common row element, or there's the user helper cell that translates into a normal div component associated with a class, a column class to that div element. So here, for example, we're specifying some further class specification. So this is part of the built-in Stipple CSS to have the ST module that will bring us some improved aesthetics. And here we have this example of a H5, so a title element that will contain the feature to be displayed. So these are the three main components to build a Stipple application. And out of this, we're able to have interactive application in place. Again, I'll return to the VS Code in order to show this in action. So here, I'm now in the scoring engine demo. So if you clone the scoring engine demo and go to the branch -172, you'll find this script, which is meant to simply show like a very minimal application. So what we do is like with any Julia script, we start loading a couple of packages. Here we have our data frames, Stipple. We had some Stipple UI for the UI library, and Stipple Plotly. So we'll use Plotly in our dashboard eventually. And then we can recognize what we've just shown in the slides, the model with those three elements, the handlers. So here I'm doing, I've added a more interesting example. So what we're gonna do is look at if there's something that happens on the element sample size or the resample component of the model. And what we're gonna do is it will be fairly trivial. We're gonna generate a random number between 100 and 1,000 and assign this as a string to our feature. So based on that, we can have a clue about what should happen. We should have simply a component to change when we click on something that will be a random number. And that's it for the handler part. The remaining element is the UI. So here you recognize a function in which we specify a Stipple page. It will contain the important element is the model. That is the basic of, well, what is the model that we bring to our front end? So all these Julia assets that we want to bring to send to our browser. And after we specified some optional options like the class or the title and some assets for the favicon, we're then defining the UI per se. And this UI is defined within a vector of components. And in those components, you recognize again what we've just discussed. So having a heading and then 2 rows, each containing a couple of content, H1 and H5. And a special element you can recognize here is the H5 component. And here what has been done is that we use the A-text macro in order to bind the feature element of the model as a reactive element. So this is it for our UI. The remaining component is to define the root. And here you might recognize something that we've just shown previously with the Genie introduction, and that is this HTML function. So if you recall, we just used the HTML and say, well, here's the string for the HTML page. And this is the very same function that we've shown in the previous example. So what having this Stipple app is all about is, again, just generating the HTML. But this time with Stipple, what we generate is a fairly more complex HTML page that contains the JavaScript elements with the Vue.js components that provides the ability to have this full interactivity of the Vue.js model in the front end that will also establish this web connection with our backend and which contains our model. So this is the definition of the root for our Stipple application, and then we can start it with this typical startup specifying a port and here the local host, and then we are saying that we don't want it to be run in asynchronously. Oh, I just it was already in use, so let's start it again. So it will show that I'm not faking anything. We'll make sure we're in the project, scoring engine demo, and we'll start this simple Stipple application. We have some, oh, I have something else running. Sorry about that. I guess it was the fault of this Genie app that was running on port 800. So let's start it again. I think this time should be good. Good, so we're now listening on port 8000. That's the default port that is used by the Genie applications. And now our application is loading, and here's the result. You can recognize what we've specified in the UI components. You can recognize the heading here, Stipple app, and then we have our first row with some components, the button, and then the second row in which we had only specified H1 text. And now if we return to our definition of the UI, we can recall that we had some action that should happen when we click the button. So here we have a button, and on click, we are saying that resample should be assigned to true. And if we recall what happened on the handler, we had said that if something happened on resample, then we verify if resample is true. And if it's the case, then we will perform this update of the content. So we're expecting some stuff to happen if we click on the button, and you can see that we have this value that has just changed. And if I click again, we have this reactivity that just happened. And this is illustrates like the very basic of how Stipple works. We can have associate any kind of HTML components with reactivity, bind to a model that is controlled in our backend in Julia. So that's really what I think what makes the magic of the framework for developing web application. And out of this very rough template, we will now look at some visualization for the model that we're having, the Flux and Evo-Trees gradient boosted tree models. And we will look how to understand the model that we've built. So now let's look at what we want to build and integrate in our dashboard. The first thing we will look at is the SHAP. So this stands for Shapley Additive Explanations. So it's a game theoretic approach to explain the output of any machine learning model. invite you to look at the detail on the paper for the details. In layman terms, this can be interpreted as a problem of allocation of the effect. So it's about understanding what are the influence if we change the input value for a given feature. How will this translate into different predictions? So this can be performed and approximated by running samples in which we're gonna make substitutions of the input features, and based on the impacts these substitutions will have on the predictions, we can build an estimate of what is the influence of changing any input of our input data to our model. So one of the beauty of SHAP is that it works with any machine learning model. The only thing that we need is to have a predict function and be able to provide a data set of observations that we want to explain. So the main function in the SHAP is the SHAP ML package in Julia that provides the main function called SHAP. And the argument that it takes is essentially explain, which is the data frame that contains the observations for which we want an explanation. We can optionally provide the reference data frame. So that could be the full data set. So this will have no influence on the time to run the explanation. It essentially serves to have provides like a better baseline for our the predictions and the effect of the explanations. And then we can specify the target features. That's also an important button we want to be able to tweak as the complexity of figuring out the SHAP effect grows exponentially. So being able to specify only the features of interest that we want to analyze can greatly reduce the computation time. And then we want to provide the name of the model we're actually building the explanation for, and a prediction function. So this predict function needs to be able to take the explanation data frame as well as the model for which we want the prediction, and finally the sample size. So this is based on the fact that we're approximating the Shapley value. So this sample size will naturally increase the computation cost, but as well increase the robustness of the estimates for the Shapley value. The result from this function is a data frame that contains one row for each of the feature and for each of the observation. So in the model that we built, we're having 14 variables of interest. And so if we pass a data frame that contains a single observation and we want the explanation for those 14 variables, well, what we get is what you see here, this 14 rows data frame. So in each of the rows, what we get is a feature name, the value taken by this particular feature, as well as here the SHAP effect, which is the information of interest for us today. And there's also an estimate of the error, so the uncertainty of that effect. And finally, the intercept is common to all of the observations. So it stands as the base point from which, if we want to reconcile the actual predictions, well, then we can start from the intercept and then accumulate all the SHAP effect to find out what is the actual final prediction of the model for this given observation. So that's it for the introduction for how SHAP works. Based on this data frame, there's a couple of interesting visualizations that can be built. A first element of interest can be the feature importance. So this feature importance plot can be familiar for those using gradient boosted trees such as XGBoost, given that it shows like the feature importance is commonly a built-in feature in those graded boosted tree algorithms. And reproducing such kind of feature importance is fairly easy. You can do it by averaging the absolute SHAP effect for each of the explanatory variable over the explained observations. So we'll look at, now I'll go into into a live session with in which we have our model that we will have load and with the prediction function, and we'll look how we can build this this plot in particular. So what we have here is all the assets that are required to build the inference out of our model. So these are the assets that we have obtained from the previous webinar. So these are the pre-processing steps along the adaptation and the actual model that we have built for each of the flux and gradient boosted tree. So I'll pass over these first steps and to go directly to the elements of interest for us today. So we have the round SHAP function that is defined here. Here we are just having a simple wrapper to define whether we want a prediction function based on if the model is a flux or a gradient boosted tree. And this will define the prediction function to be used based on the name of the model. Otherwise, what we're doing is simply calling the SHAP-ML explanation function. So here I'm then defining some feature importance, the list of variables we want explanation for, and then we will go to the SHAP importance. So what we're doing is just take a small sample of observations. Here I'm taking a sample of size 50 for this sample size, and for the number of explanation size, and the sample size 30. And what we're going to do first is call this SHAP function. So the result is what we've shown. Only difference is that we now have 700 rows because we have 14 features times our explanation size of 50. And the other point when we want to build this importance plot is to convert this by averaging the SHAP effect over all of the variables. To do that, it can be useful to develop ourselves some helper function. So this is what has been done in the explain script. So this script is part of the source code called explain.gl. And what we do is very simple, and it's used the data frame transform function. And what we do is that we are calling importance, SHAP importance. Yeah, here we go. It wasn't the right function. So what we're doing is we're going to aggregate based on the a grouping from the feature name, and then combine by taking the mean of the absolute value of the SHAP effect. And finally, we're doing a sorting so that our plot will show decreasing feature importance of the variable. So if I execute this function, what I get is a data frame that contains only the 14 rows, so one row for each of the feature along the average absolute effect from the Shapley value. I can repeat now the same step for the gradient boosted tree model. And once I have this data frame, another helper function will be to build the plotly figure. To do that, we'll pass the data frame of the feature importance, and we will return the trace that contains the bar plot. So this is the SHAP importance helper function, and we define a trace that is a plotly base. We have a bar plot, and we can specify that the X value is the SHAP effect, and the Y is the name of the feature. And then we can tweak a little bit our layout, controlling the background color, the title, and some other attributes of interest for or aesthetic concerns. So that's the result that we get when we're calling this function. Now we have this fine-looking plot. So this is something, the process that will repeat for some other plots of interest. For example, a Sharp effect for looking at the one-way effect of a given plot. So what we're going to do is to look at, if we take a large number of samples, how will the model behave for a given variable along all of its possible value. For example, I'll do this on the vehicle age, and I'll use the plot to illustrate the interesting part of it. So here, this is for the vehicle value. So what we're interested in is to look at, well, if we change from a vehicle age from 0 up to 20, how will this affect the prediction of our model? So the Shapley value allows us to have this comparison, and by having the overlay of the two models, flux and gradient boosted trees, we can appreciate the difference that, for example, the gradient boosted trees having a steeper effect, while the flux model has kind of a more flattened structure. Finally, a third plot we'd like to take a view is to explain a single observation. So that is how we can start from this baseline that we mentioned of the baseline prediction, and have combine all the effect of all the variables into a final prediction. To do that, we can just look at the Sharp effect and use the waterfall plot. I'll execute the script here and show you the result, and then how we can get to this kind of plot. So what is being plotted here is only the accumulation of all the Sharp effect that we've seen for for each of the variable, and we've sorted them based on the absolute value of their effect. So we're starting from an effect of 0, and we start with the vehicle age that has a great negative impact on the prediction. And then we can move on the coverage, a maximum coverage, which now increase the prediction of the probability of having a claim. And we go on throughout all of the predictions to end up with an effect that is about minus 1.2% reduction in the prediction of a risk. And we can have a quick view on how this translates based on the influence of each of the variable. So it's easy to see well that our variables that are key to our prediction are the vehicle age, followed by the policy coverage, and then the duration of that coverage. And now a last kind of plot that I wanted to show is not based on the Sharp, but just on those basic one-way exploration of the model. And here, what we're going to do is simply to look at the aggregation of the effect over all of our observations. So here, what we need to do to perform this kind of plot is to add the predictions for all of our data sets for both our model, so the flux and the gradient boosted tree model. And then we're gonna group the feature based on some bins. So we can make cutoff based on the quantiles. So here we can have 10 quantiles, and then we're gonna aggregate over those 10 quantiles and take the mean value for the target variable, named the effect. So this is the red curve, and then we can compare with the actual predicted target from the flux model in green, or the gradient boosted tree in purple. Let's look at again how we can perform this. This is the one-way effect. So what we're doing here is having this add scores first to add the predictions on all of our predictions. And the next step we're going to do is to define the bins for example, the driver age. So what we're performing as an operation here is the one-way data. So that's, again, it's an helper function that we define because we know we'd like to repeat often those kind of groupings. And this bin var, what it does is to figure out what are the edges. So if we define the method that is the quantiles, it will look at the quantile for our variable of interest based on the number of bins. So it will be the quantiles from 0.1 to 1. And based on those edges, we're now able to create an indicator variable based on the search sorted last that will assign each observation into its associated bin. So the result will be that our variable, or our new transform variable, will take a value between 1 and 10 based on the quantile. Or if we use the linear method, it will create breaks on an even scale basis. So now we could have like a not even number of weight in our data frame. So this is the result of our bin variable. So you can see that the variable bins take values 1 to 10, and we have the content is the average effect for our variable of interest, the event, and then each of the flux, GB3 predictions, and the weight of our variable. Again, we create a helper function for plotting, and we're able now to generate a Plotly graphic out of this helper function. And to have an idea of what this helper function is about, we can see that there's a couple of traces. So what we do is that we are looping over in this function of a one-way plot. We're going to loop over the target, so the event, the flux, and the GB3. And for each of those targets, we're going to add a trace that contains a scatter markers plus lines, and the target is the name of the variable in the data frame of interest. So this is can be an example of a trick that we can use to easily generate a more complex plot with a variable number of traces. And then so that's it for the plots that we want to put in. And now that we have all these components in place, we can be interested into having this final final Stipple applications. The beauty is that once we've made this kind of ad hoc exploration of our plots, we pretty much have everything in place to build a complete application. Because all we need to do now is just to articulate what we want to specify as being variable components. So here in our Stipple application, you'll find everything in the bin main.gl file, and we've split up the application between an initial setup that contains the initialization of our model, so loading the assets for the model, and then we have an application and a UI. So the application contains our structure. You'll find out here the same kind of reactive model structure, and then we have the assets for each of the plots we're gonna include in our application. For a Plotly, there are three components. There are the traces, there's the layout, and the configuration. Often the configuration doesn't need to be changed, so you could reuse the same configuration for all of your plots. But oftentimes you will want to have at least the trace and the layout to be a reactive component. So this is how you can specify the model assets for each of the plots. And then what we have, the remaining part that we want to have is how we're gonna update the plot if we change an input to our model. And then you'll recognize the same kind of code that we use when we initially did our model exploration. That is using the one-way data and the one-way plot helper generation. And once we've generated this Plotly assets, we can assign them in our model. So this plot function generates the Plotly assets, and now we're assigning those Plotly assets into our reactive model. And this is all there is in order to update our interactive applications. Now on the final step is the UI component. So again, it's the page. And what we have is the same structure that we've had previously when we made the initial development of this skeleton that contained very basic text content. The difference will be mainly for the plots. So you'll find like a row in which we're going to include plot elements. And these plot elements contains those traces, the one-way traces, one-way layout, and one-way config. And we do that for all of the explanation plots, and as well as the one-way plot and the feature importance figures that we've previously built. Once all that is in place, we can now go to the execute that code, and we actually have this already running here. And this is the result that we'd get once the application is launched, is we're now having a complete interactive application that we recognize here some of the buttons that we're having. We can click on them, and the impact will be to update the sample. We can change the sample size of the observations we want to explain, or we can as well change the feature value that we want to explore, and as well as the grouping method, and see how this translates in the various explanation tools that we built. So yeah, we're about to go throughout our allocated time. So I just want to take some time to take questions that we might have, as this has been a bit went quite quickly over all the content. So I don't know if they were having any questions at this stage.
Yeah, there are a couple of questions in the chat section, and there's a question in the Q&A also.
Yeah, so the first one I'm seeing, there's to select points in Plotly and send them to their indices back to the backend. Good question. I don't know if I haven't performed this. I know there's a reactivity component. This is something I would need to inform myself to get back to you if this is something we can that is readily available and easily, that can be performed easily. That's a good question. I don't have an answer to. Yeah, so I'm going back in the chat. I'm a question about to have the dashboard running permanently. And then I assume we have to start it somehow, but without any manual operations. So an example of this right now, for example, on JuliaHub, what I did to launch the applications is that I had registered the application here as a custom app, and I started it as an application. So I went here, I selected, let's say, launch a new instance. It will be a single process, and I have it run on 4 CPUs, and then I would specify the amount of time. So here, by default, we're not having like the permanent option. I think it's something that could be easily added, but you can have this option to just launch your application, specify that it's the port number 8000. Here we would select the branch -172, and then we can have it run, let's say, for the next, I'm not sure about the limit, if we have any limit time that we can specify, but that would be, I think, the easiest option to just get it run out of JuliaHub. Yeah, so permanent, it can be a standard deployment on the app with Docker on-premise in the cloud. So yeah, so a Stipple app is it remains just a fundamentally it's a Julia script, so you can for sure build this app. It's a Julia package that actually we've been developing, and so you can install this Julia package into a Docker container, and then have this Docker container run on the cloud. Something I already tried is making it run on the actual EC2 or another kind of cloud provider server, and then run the app, and having the access to that app controlled based on the Nginx reverse proxy. So that can be a way to make to handle like more complex situation where you want to have an app served to the outside world. So there are really kind of a large number of options that are available. So here it was just an example. If you don't want to have any kind of a IT overhead, you can just go on JuliaHub and spin the app as a custom application. Can be a simple option. Are there some other way to serve this with auto scaling, Google App Engine? So I don't know about the scaling options. I'm not sure if we can have like an example of an answer about those kind of scaling examples. I think we're to have Adrienne on this webinar, so I don't know if you will be able to answer this question. I can answer for Google App Engine, unfortunately. I haven't tried like the integration with Franklin. I would say that given like the flexibility of the Genie framework, so far this has been my go-to, is to simply integrate the Stipple application within more of a static kind of web page. What you can see is that in Genie there's the support directly for Markdown pages. So you've noticed we were using the HTML function that takes a raw string of valid HTML content, but there's also the Markdown MD function that is meant to parse Markdown content. So I think it can be a way to deal with those kind of content if you have more kind of doc pages or more blog content you want to write directly into Markdown. Genie is well adapted to serve those kind of Markdown content as well. So I would, maybe my first reflex will be to suggest taking a look at doing this kind of integration directly with Genie. I hope this might help. I don't know, Sanjeev, or if anyone had noticed some other questions that I might have missed.
In the Q&A section, there was a question. Did you, by Sheikh Alam?
Oh, yeah, that's an interesting question for the hot reload. Yeah, so you need to opt in for that, in the sense that, for example, by default, I'll try to return to an example of the code to illustrate this. When I did the inclusion of the code, for example, here I use the include T. So this is like it's a revised variation on include. So it's a way to track the code versions. So if you have your code that lives inside an actual package, so if you have a workflow where, for example, your helper function or the handlers are defined into a module, and you load that module, then Revise will capture those changes in the code. So you'll get this interactive development experience where you can change elements in the page UI, for example, or you can change your handlers and just return to your web page, reload, and you'll have those change taken into account. So the only thing that might not work out of the box is if, for example, you're kind of going in the perhaps a rough way where I've just made a straight script in the Stipple intro, for example. We're not part of a module or anything, so there's the variations of the code will not. If I would have changes the text here, the change will not be reflected into the application because we're not like the code is not coming from a revised script, so the code is not tracked here by default. So I think it can be a way to encourage you maybe to have a more clean way to organize the code, put it into modules, and get this interactivity in the development workflow. About the ability to make the app available only to select users, the answer to that is yes. There are plugin extensions that exist. Can look at them. They are named. There's the Genie authentication and there's the Genie authorization. So for specific users, you will need to use the Genie authorization and define the roles and permissions associated with those users. So this involves like managing the SQL backend. So you need to have, for example, the SQLite in place. Well, that's what the actual plugins gives you. So it creates this model for this authorization model with the SQL backend to handle those kind of scenarios.
Yeah, in case you have any questions, please type it in the Q&A section and we'll pick it up from there.
Yeah, absolutely. And there's also there's the repo, the scoring engine demo.gl that is public. So don't hesitate to file an issue or anything if you have some questions about how this app development has been made. So I know we went quite quickly over the demonstration of how those helper functions were built, but hopefully I think executing the code of the main.gl in the bin under the bin main folder. This is really like what is executed for the app. So from there, you should be able to figure out like the dependencies that are used. And if there's any questions, don't hesitate to open issues around that. Hopefully, it should run out of the box. If you're at least on the Julia 171 or 172, the branch is functional for the various users we've tested it with. All right, so we're now past our time. So thanks everyone for joining the webinar.
Thank you everyone, and the webinar recording will be available on Julia Computing website in a day or two in case you want to view it. Okay, thank you everyone, and thank you Jeremy for this lovely webinar. And if any one of you have any questions, you can drop us an email at sales@juliacomputing.com and we'll answer your queries. Thank you everyone. Have a good day.